This is SpaceTime, Series 25, Episode 106. Coming up on SpaceTime, NASA's Juno spacecraft undertakes a close flyby of the Jovian Ice moon Europa. A planetary-scale heatwave discovered in Jupiter's atmosphere. And SpaceX launches another 52 Starlink satellites into low Earth orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Juno spacecraft has undertaken a close flyby of the Jovian Ice moon Europa. The spacecraft flew within 358 kilometres of the mysterious world's frozen surface. The flights provided scientists with some of the highest resolution images ever taken of portions of Europa's surface, as well as collecting valuable data on the moon's interior, surface composition, ionosphere, and its interaction with Jupiter's magnetosphere. All this data will help scientists as they develop future missions to the European system, including NASA's Europa Clipper spacecraft, which is set to launch in 2024. Juno principal investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says Europa is an intriguing world with a global liquid water subsurface ocean that could harbour life. The ice moon is some 3,100 kilometres wide. That's almost as big as the Earth's moon. And Europa's oceans contain more water than all the Earth's oceans combined. The Juno flyby was designed to modify the spacecraft's trajectory, reducing the time it takes to orbit Jupiter from 43 to 38 days. It was the closest the spacecraft has approached Europa since NASA's Galileo spacecraft flew within 351 kilometres of the Moon back on January the 3rd in the year 2000. The flyby also marked the second close encounter with a Galilean moon during Juno's extended mission. Juno explored Ganymede in June 2021, and the spacecraft will make close approaches to Io in 2023 and 2024. Data collection for the Europa flyby began an hour prior to closest approach, when the spacecraft was still some 83,400 kilometres from the Galilean moon. The relative velocity between the spacecraft and Moon was a blistering 23.6 kilometres per second. Juno's full suite of scientific instruments and sensors were activated for the close encounter. Its Jupiter Energetic Particle Detector instrument, or JEDI, and its medium-gain X-band radio antenna collected data on Europa's ionosphere. Juno's WAVES, Jovian Auroral Distribution Experiment, JADE, and magnetometer experiments measured plasma in the Moon's wake as Juno explored Europa's interaction with Jupiter's magnetosphere. Scientists also undertook a search for possible water plumes above Europa's surface. Juno's microwave radiometer studied Europa's water ice crust, obtaining data on its composition and temperature, the first time such data was collected on the Moon's icy shell. The Juno science team will compare the visible light images captured during this close encounter with images from previous missions, looking for changes in Europa's surface features, which might have occurred over the past 2 decades. Although Juno was in Europa's shadow during closest approach, Jupiter's atmosphere reflected enough sunlight for Juno's visible light images to collect data. The spacecraft's stellar navigation camera gathered high-resolution images of the Moon's surface, while its infrared auroral mapper captured infrared observations. The Juno data will be fed to the Europa Clipper mission, which will perform nearly 50 flybys of the tiny world when it arrives at Europa in 2030. Europa Clipper will gather data on the Moon's atmosphere, surface and interior information, data which scientists will use to better understand Europa's global subsurface ocean, the thickness of its ice crust, and possible plumes which may be venting subsurface water into space. Similar geysers were spotted emanating from tiger stripes near the south pole of Enceladus, one of the ice moons of Saturn, which also has a global subsurface ocean and which is also considered a possible location for life. This is SpaceTime. Still to come, a planetary-scale heatwave discovered in Jupiter's atmosphere, and our nearest neighbouring star system, Alpha Centauri, 2 of our nearest neighbouring galaxies, the Large and Small Magellanic Clouds, and 3 meteor showers are among the highlights in the October night skies on Skywatch. Astronomers have detected a planetary-scale heatwave sweeping across Jupiter's atmosphere. The findings, reported to the Europlanet Science Congress in Granada, show the unexpected heatwave reaching temperatures of more than 700 degrees Celsius. The event is expanding the Jovian atmosphere, extending it out by some 130,000 kilometres. That's about 10 times the size of Earth's diameter. Jupiter is the largest planet in our solar system. In fact, the gas giant has more mass than all the other bodies in the solar system combined, other than the Sun. The planet is more than 5 times further away from the Sun than the Earth, and has a vibrant active atmosphere full of multicoloured longitudinal bands and stormy vortexes. The engine powering these remains somewhat of a puzzle, as Jupiter only receives about 4% of the sunlight that the Earth does. And so its upper atmosphere should theoretically be a frigid minus 70 degrees Celsius. Yet for some reason the cloud tops of Jupiter reach temperatures exceeding 400 degrees. Heat maps suggest Jupiter's bright aurorae may be a possible heat source. Unlike Earth's somewhat transient northern and southern lights, the aurora borealis and aurora australis, which are only ever generated by intense solar activity, Jupiter's aurorae are constant. They're partly generated by the solar wind, but also by volcanic activity blasting into space from the Galilean moon Io. The study's lead author, James O'Donoghue from JAXA, the Japan Aerospace Exploration Agency, says the Jovian aurorae heat the region around the poles to over 700 degrees Celsius. Global winds then spread this heat to other parts of the atmosphere. The new research by O'Donoghue has identified a significant heat wave under the Jovian North Pole, which is spreading towards the equator at thousands of kilometres per hour. He thinks this heat wave could have been triggered by a pulse of enhanced solar wind plasma interacting and impacting with Jupiter's magnetic field. This then boosted auroral heating, forcing hot gases to expand and spill out towards the equator. O'Donoghue says that while aurorae continuously deliver heat to the rest of the planet, these heat wave events represent an additional significant energy source. He says the findings add to science's knowledge of Jupiter's upper atmospheric weather and climate, and they're of great help in trying to solve the energy crisis problem that plagues research into the giant planets. SpaceX has launched another 52 satellites into low Earth orbit. The mission, which launched from Pad 40 at the Cape Canaveral Space Force Base in Florida, was on a unique flight path which allowed people as far north as Maryland, New Jersey, New York and even Cape Cod in Massachusetts to see it. The Falcon 9 rocket core stage returned safely to Earth, landing on the drone ship a shortfall of gravitas, which had been pre-positioned downrange in the North Atlantic Ocean. SpaceX has now launched some 3,399 broadband internet satellites, despite protests by astronomers whose vital research is being disrupted by the constant trains of satellites polluting their observations. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for October on Skywatch. October is the 10th month of the year, and that may seem confusing since octo in Latin means 8 rather than 10. The answer lies in the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. Of course, the highlight of October for kids and those who are young at heart has to be the last day of the month, celebrated as All Hallows Evening or Halloween. Halloween is based on ancient Celtic pagan festivals such as Samhain, the Gaelic festival of the dead. Samhain was eventually Christianized by the early church to become All Saints or All Hallows Eve, or simply Halloween. It's a time when darkness overtakes the light of day, a reference to the increasing hours of darkness as the planet's northern hemisphere moves towards longer winter nights. And so it's a time when the harvest comes to an end. The increased hours of darkness mean the boundary between the world of the living and the world of the dead becomes especially thin, allowing the dead and supernatural to rise in search of the living. And so the living wear disguises so as not to be recognized by the dead. and it's this which has led to today's tradition of the Halloween fancy dress party. In some parts of the world, cross-dressing is popular on Halloween, a reflection of the secret desires and fantasies of their pagan ancestors, sometimes not so many generations removed. To ensure that crops and livestock survive the cold winter months ahead, offerings of food and drink would be left outside for the spirits and fairies of the other side. And it was this which ultimately led to today's practice of trick-or-treat. Also, candles would be lit and prayers offered to the souls of the dead, as Halloween was a time when the spirits of the dead would return to their former homes. Special bonfires were also lit on Halloween to light the darkness, thereby preventing souls of the dead from returning and keeping the evil away. The flames, smoke and ashes were deemed to have protective and cleansing powers and were used for divination. As for the tradition of carving pumpkins into jack-o'-lanterns, well, that was originally meant either to represent spirits or supernatural beings, or alternatively to ward off evil spirits. In many parts of the world, the Christian religious observances of All Hallows' Eve include attending church services and lighting candles on the graves of the dead. And Christians historically abstained from eating meat on All Hallows' Eve, a tradition reflected in the eating of certain vegetable foods on the day, including apples, potato pancakes, and soul cakes. Apple bobbing originated because the apple was a Celtic symbol of love, and so grabbing the apple with your teeth had certain erotic overtones. Halloween is a time of fortune-telling and divination games, playing pranks to scare people, visiting haunted attractions, telling scary stories, and of course watching horror movies. Looking to the southwest, you'll see the two bright pointer stars, which show the way to the Southern Cross. The brightest, and what also looks like the more distant of the two stars from the Southern Cross, is Alpha Centauri, which is actually the nearest star system to our own solar system. Alpha Centauri is a triple-star system comprising two stars, Alpha Centauri A and B, which orbit each other in a binary, and a third star, Proxima Centauri, which orbit the pair. Like the Sun, Alpha Centauri A is a spectrotype G yellow dwarf star. It's about 10% more massive than our Sun and about 1.5 times as luminous. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. They're followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, spectrotype G yellow stars, that's where our Sun fits in, spectrotype K orange stars, and the coolest and least massive stars of all are the spectrotype M red stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now you put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarves, some of which were actually born as spectrotype M red stars, but became brown dwarves after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can be up to 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarf stars we mentioned earlier. These can be 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Alpha Centauri A's binary partner, Alpha Centauri B, is a spectrotype K orange dwarf star, a little smaller and cooler than its companion, with about 90% of the Sun's mass and about half its luminosity. This binary pair, Alpha Centauri A and B, orbit each other at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres, or around 8.3 light minutes. So the pair's orbit around each other varies by between the average distance between the Sun and Saturn and between the Sun and Pluto. It takes the two stars 79.91 Earth years to complete each orbit. On average, Alpha Centauri A and B are located 4.37 light years from the Sun. Now, although a light year sounds like a measure of time, it's actually a measure of distance. A light year is a distance of about 10 trillion kilometres. That's the distance a photon can travel in a year at the speed of light, which is around 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The third star in the Alpha Centauri system is a spectral Type M red dwarf star named Proxima Centauri. Right now, Proxima Centauri is just 4.25 light years away, making it the nearest star to the Earth other than the Sun. It is only loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units, or around 0.21 light years. That's about 430 times the size of Neptune's 30 astronomical unit orbit around the Sun. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting within the habitable zone of Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The habitable zone, which is sometimes also referred to as the Goldilocks zone, is that area out from a star where it's not too hot, not too cold, but just right for liquid water, essential for life as we know it, to exist on a planet's surface. The planet, known as Proxima b, takes just 11 Earth days to complete one orbit around its host star. That's far closer than Mercury's 88 Earth day orbit around the Sun. A few years ago, a second, more distant planet, Proxima c, was also discovered orbiting around the star, but well outside its habitable zone. The second and slightly fainter of the two pointer stars is Beta Centauri, and while Alpha Centauri is the third brightest star in the night sky, outshone only by Sirius and Canopus, Beta Centauri is only about the 10th brightest. Looking to the southeast, and you'll see the bright blue-white star Alpha Eridani or Achernar, which represents the southern tip of Eridanus, one of the largest and longest constellations in the sky. Achernar is located about 139 light-years away. It's actually a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. Alpha Eridani A is a hot young spectral Type E blue star. It has about 6.7 times the mass of the Sun, and a stunning 3,150 times the Sun's luminosity. By comparison, the companion star Alpha Eridani b appears to be a spectral Type A white star with about twice the Sun's mass. The two stars orbit each other every 14 to 15 Earth years at an average distance of about 12.3 astronomical units. Because of its high rotation rate of over 16 kilometers per second, Alpha Eridani A is actually one of the least spherical stars in the Milky Way, spinning so rapidly it's assumed the shape of an oblate spheroid, with an equatorial diameter 56% greater than its polar diameter. This distorted shape means the star displays a significant latitudinal temperature, with its polar temperature being about 20,000 Kelvin, while its equatorial temperature is only around 10,000 Kelvin. That's because it's much further away from its stellar core. The high polar temperatures are generating a fast polar wind. That's ejecting matter from the star and creating a spectacular polar envelope of hot gas and plasma. Now, if you look up between the South Celestial Pole and Achernar from a really dark place, you'll see two faint fuzzy-looking clouds. Now, these aren't actually clouds. They're two satellite dwarf galaxies which orbit the Milky Way, known as the Large and Small Magellanic Clouds. They're named after Ferdinand Magellan, who became the first European to officially record them during his expedition to circumnavigate the Earth between 1519 and 1522. The bigger and nearer of the pair is the Large Magellanic Cloud, which is located around 160 light-years away. It's easy to spot about halfway between Achernar and the horizon. It's about 14 million light-years across, twice that of the Small Magellanic Cloud, which is located a more distant 200,000 light-years from the Milky Way. Now, by comparison to these two satellite galaxies, the Milky Way is huge, 100,000 light-years across. These two dwarf galaxies are separated from each other by roughly 75,000 light-years. The Magellanic Clouds were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius dwarf elliptical galaxy and the 2003 confirmation that the Canis Major dwarf galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds is uncertain. Only a fraction of their gas seems to have coalesced into stars. They also probably both have very large dark matter halos. Still, one recent estimate places the total mass of the Large Magellanic Cloud at about 1/10 that of the Milky Way. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions as they're gradually torn apart and absorbed by the Milky Way. These huge tidal forces have turned both Magellanic Clouds into irregular disrupted barred spiral galaxies. The Large Magellanic Cloud still retains a very clear spiral structure, at least in radio telescope images of neutral hydrogen. But gravity isn't a one-way street, and the combined gravitational force of both Magellanic Clouds is also affecting the Milky Way, distorting the outer parts of our galactic disk. And there are streams of neutral hydrogen gas clouds and isolated stars, connecting both dwarf galaxies to each other and to the Milky Way. A brilliant example of galactic cannibalism at work. Now, if you look just above the small Magellanic Cloud using a backyard telescope or a good pair of binoculars, you'll see a small blurry dot. That is the 47 Tucanae globular cluster. A tightly packed ball of stars some 16,000 light-years away, they were all originally formed at the same time through the gravitational collapse of the same molecular gas and dust cloud. If you look to the west, you'll see the bright reddish-orange supergiant star Antares, the heart of the constellation Scorpius the Scorpion. And above it you'll see a bunch of stars stretching out shaped like a reverse question mark. That's the tail of the Scorpion. Now, just above and to the north is the constellation Sagittarius the Archer. Sagittarius shows the way to the supermassive black hole at the centre of the Milky Way galaxy, some 27,000 light-years away. This monster black hole, known as Sagittarius A star, has about 4.3 million times the mass of our Sun. Now, looking to the north-northwest this time of the year, you'll see the constellation Lyra the Harp, and its brightest star Vega, the fifth brightest star in the night sky, and one of the closest at just 25 light-years away. Vega is a spectral type A white star, more than twice the size and some 40 times the mass of our Sun. Now, just to the right of Lyra, and almost directly north just above the horizon, is the constellation of Cygnus the Swan, and its brightest star Deneb, one of the most luminous stars in the sky. Deneb is a massive spectral type A white supergiant, some 19 times the mass and over 100 times the diameter of the Sun. The star is somewhere between 55,000 and 196,000 times as luminous as the Sun. The huge range in luminosity estimate is caused by the difficulty in determining Deneb's exact distance from us. Science's best estimates place it somewhere around 2,600 light-years away, give or take 212 light-years. High in the northern sky right now is the constellation Aquila the Eagle, and its brightest star Altair. Altair is another spectral type A white star, but located a lot closer, just 17 light-years away. It's about 10 times brighter than the Sun, with about 1.89 times the Sun's mass. Despite its size, Altair spins on its axis in just 10 hours, compared to our Sun's 28 Earth day rotation. Now, these three stars, Altair, Deneb and Vega, form a stellar grouping known as the Summer Triangle. Now, also in October, there are 3 meteor showers: the Draconids, the Torrids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out from the constellation Draco the Dragon, and so are best viewed from the northern hemisphere. They're actually produced as the Earth's orbit takes it through the debris trail left behind by the comet 21P Sciacobini-Zinner, which takes about 6.6 Earth years to make a single revolution of the Sun. The Torrids meteor shower takes place on October 10th, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Their meteors are composed of larger-than-average pebbles and dust grains, and are thought to be generated by debris left behind by the comet 2P Encke, although it's thought that both the Torrids and Encke could be the remains of an earlier comet which disintegrated over the past 20,000 to 30,000 years, breaking into several pieces and releasing material both by normal cometary activity and possibly also by gravitational tidal interactions with the Earth and other planets. The Torrids debris stream is the largest in the inner solar system, taking the Earth several weeks to pass through and resulting in an extended period of meteor activity compared to other meteor showers, which are usually over in just a matter of days. Now, due to the gravitational perturbations of the planets, especially Jupiter, the Torrids have been spread out over time, allowing separate segments, labelled the northern Torrids and southern Torrids, to be observable at different times in different hemispheres. The southern Torrids are active from around September the 10th to November 20th, while the northern Torrids are active from October the 20th to December the 10th. The third meteor shower this month is the Orionids, which peak on October the 20th. They're caused by debris from the comet Halley, which also causes the Eta Aquarids meteor shower in May. Comet Halley takes 76 years to complete each orbit around the Sun. It'll next become visible near Earth in 2061. The Orionids are equally spectacular in both northern and southern hemisphere skies, with up to 20 meteors an hour radiating out from the constellation Orion. The best time to see the Orionids is just after midnight and right before dusk. And now, with more on the October night skies, we're joined by Jonathan Nally, editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, the seasons are changing. Thank goodness the cold of winter is disappearing from where I live, at least, and we're in spring now and heading towards summer. For those of us at mid-southern latitudes, a couple of months' time, it's going to be too hot. We'll be complaining about that, but we'll get to that when we get to it. But actually, for me, I've worked out I'm more of a summer stargazer than a winter stargazer, because winter stargazing is just too cold. You don't want to go outside when it's really, really cold. Not that I live in a terribly cold place, but it's cold enough that I don't want to do it. I'd rather go out in summer. But anyway, look, I like the constellations of summer even better than the winter constellations. There are some great things to see up in the sky as we get towards the end of the year. So anyway, what can we see in October? Well, for us, we're down in the sort of southern hemisphere, in the mid-southern latitudes. Way down south this time of year, we've got the Magellanic Cloud Galaxies. So these are really great things to see if you've got some dark skies. These are the two nearest fairly large sizable galaxies outside our Milky Way. They're named after the explorer Magellan, the Magellanic Galaxies. So they're down there, down to the south, about halfway up from the horizon. You've got the two of them, the small and the large. I don't need to explain why that is the case. One is small, one's large. But you do need dark skies to spot them. If you're in the middle of a city and you've got lots of street lights and everything around, and you've just walked outside from inside a brightly lit place, and your eyes aren't adapted to the dark, you're not going to see them. But if you can find yourself a dark spot and look down to the south, you should be able to make out these just two faint fuzzy clouds. And if you get to a really dark spot, if you're out in a sailing boat in the middle of the ocean, or you're out in the desert or something, they really stand out and they look fantastic. Now, if you're looking for the famous Southern Cross down there in the south and you can't find it, don't panic, because at the moment it's upside down and either right on the southern horizon or even below it, depending on exactly where you are in the south. If you're as far south as Melbourne or Hobart, you should be able to see it, but if you're up in the far north of Queensland, for instance, you're not going to see it at all, because it's just the way it's orientated at this stage of the year. It's right down the southern horizon. Overhead, the sky actually seems reasonably empty at this time of year, at least in the evening hours. There are some big constellations up there, but they're pretty dull from a naked eye point of view. You've got Capricornus and Sculptor and Aquarius and Cetus and some other ones like that. They've got some great things to see if you've got a telescope, but to the naked eye they appear pretty bare. The northern part of the sky seems pretty devoid of interesting things to see at this time of year as well. At least in the western sky, you've got the bright stars of Scorpius and Sagittarius still, but they're getting lower and lower in the sky as each night passes. This is how you can tell the seasons are changing, because certain constellations are disappearing from view and they won't be back for 6 months or more, and other constellations are starting to appear. So if you like staying up late or you get up early, then the skies after midnight in October are really good, because you've got the Milky Way rising in the east, and it's bringing with it the fabulous constellations, the ones I really love. You've got Orion and Taurus and Gemini and Canis Major and Puppis and all sorts of other ones that have lots of interesting stars and deep sky objects that astronomers really love. Those sort of constellations, I really love them, because when I was first getting into stargazing in my sort of mid-teens, it was summertime and these constellations were out. I just go outside in my shorts and t-shirt, because the temperature was really lovely, with a pair of binoculars and just start sweeping around.
So this is after the Ice Age?
Only just. Start sweeping around the sky with the binoculars, and just, there are so many good star clusters and things to see, and nebulae. It's just really fabulous. And when you realise that these are real objects out in space, you've seen pictures of them in books and magazines, but when you go out and you say, wow, that's what I saw in the magazine, that is a real nebula. There's the Orion Nebula, or there's this star cluster or that star cluster. It really is fabulous, and it really connects you with nature in the grander scale. I mean, nature here on Earth is brilliant enough, but you add the cosmic dimension of it as well, looking deep out into space, light years and hundreds of thousands of light years out into space. It's just really tremendous. It really broadens the mind. It's a great thing to do. Above the northeastern horizon in Taurus, two of these star clusters I was just talking about, you've got the Hyades and the Pleiades. both of which look great through binoculars. Pleiades is also known as the Seven Sisters because many people can see 7 of the stars just with the naked eye. And there are actually several hundred, I think, stars in that star cluster, and you can see more and more of them the bigger the optical aid. So if you've got a pair of binoculars, you'll see more stars than 7. If you've got a telescope, you'll see even more still. If you've got a bigger telescope, you'll see more still. So it's a beautiful thing to see. Interesting thing about the Pleiades is that in Japan, they're known as Subaru. So if you look at the emblem on the front of a Subaru car, you'll see it's a little group of stars, and that is the Pleiades or Subaru.
And the Subaru telescope uses the same emblem.
It does. And the other interesting thing about the Seven Sisters, I think no one's really got to the bottom of this, is that different cultures all around the world that were separated prior to the modern age, whether it's in Australasia or Southern America or Asia or wherever else, so many different groups looked at these little group of stars and called them the Seven Sisters or the something sisters.
Yeah, they're always 7 females, aren't they? It's It's like going back to some ancient tribal memory from Africa almost.
Well, I think it's because they're actually sparkly and pretty, and I think that they associate that with femininity, if you like. So Venus, planet Venus, which is actually an awful place, but it looks really nice in the sky. It's big and bright and beautiful and sparkly, looks like a diamond. And so for a long time, it's been Venus, the goddess of love and all that sort of thing, because it just looks so bright and sparkly. Whether you agree with that or not, that's the reason why they did it. So it's interesting that the Seven Sisters are known as sisters in all these different cultures around the world that didn't really have communication at all.
Also, they're all being chased by a hunter, which is another interesting aspect of the story. In many cultures, I mean, we're talking about Orion here.
Orion the hunter, yeah. Yeah, it's interesting that...
I mean, it is interesting with the flood stories. Most cultures have a massive flood story and revitalization after the flood. That all goes back to the ancient Mesopotamian times.
That's right. Yeah, there's all sorts of these stories are very similar around the world. Yeah. But anyway, you look up in the stars, look up at the sky and see these stars, and that's another sort of connection you could have with history, because people have been seeing these stars for thousands of generations, looking up and wondering what they are. We're actually really lucky. We live in a time that we know what they are. I mean, we only really know what stars are, less than 200 years or something like that. So, and as far as their distances are concerned, even a shorter time span than that. So we're living in a fantastic era for actually knowing what these stars are.
There's still debate over the exact distance to the Pleiades.
Yeah, and lots of other things too. So, for instance, talking about Orion, so you've got the two of the bright stars in Orion. You've got Rigel and Betelgeuse. They're the famous big bright stars in Orion. Now, those stars are quite different to each other. You've got Rigel, it looks like a bluish-white star, but it's actually at least 4 stars in close proximity. The main one of those stars, Rigel itself, is about 20 times as massive as our sun, and it's hundreds of thousands of times more luminous. Hundreds of thousands of times more luminous. And it's about 363 light years away. Well, that's pretty specific, isn't it? It's about 363 light years away. Betelgeuse, on the other hand, is a huge supergiant red star, and it's about 120,000 times as luminous as our sun, and it's a single star. It's also what's called a variable star. Its brightness varies by a noticeable amount over a certain period. Sometimes it's brighter than Rigel, sometimes it's a bit dimmer, so sometimes it's the 6th or 7th.
6th or 7th, yeah.
Brightest, depending on whether it's brighter or not. But the interesting thing about it is they're not quite sure how far away that one is either.
Yeah, they've worked out it's a little closer than they thought it was, and so that means it's not necessarily as big and bright as they previously thought it was, because it's closer.
Yeah, I mean, it's really interesting. So we're still living in a time where we're learning lots of things about stuff that we have thought is pretty well set. But look, that's the way science is, and that's the great thing about science. We just keep refining it, and as new data comes in, more data comes in, we adjust our thinking about it. So anyway, Orion, if you're up early in the morning, you should be able to see Orion out there in the east. You can't miss it. I mean, it's just the most unmistakable group of stars. But as the next couple of months go on, that's going to rise into our evening skies. And so by the end of the year, you'll be able to go out in the evening and see this beautiful constellation. For us here in the south, in lovely sunny weather. For our friends up in the northern part of the planet, unfortunately colder weather, but nonetheless it should be pretty great to see.
When you go out to look at the night sky, I like to use either the Southern Cross or Orion as my initial reference point to work out exactly what part of the sky I'm looking at.
Yeah, that's right. I mean, if you took someone outside and sort of blindfold them and span them around, and they stopped and took the blindfold off, you could know where you are just by finding the Cross or Orion. And for our friends up in the north as well, you could have the Big Dipper or the Little Dipper or the star Polaris. You can see what why. When some people say, what has astronomy ever done for us? Well, I say thousands of years of navigation, folks. thousands of years of navigation. It's what people used to navigate around.
When to grow crops.
Yeah, our entire timekeeping system, our entire calendar, the whole thing has been based on our observations of the seemingly unchanging stars. So it's given us quite a lot, in fact. Anyway, let's get on to the planets.
Could go on. Yes, planets. Tell me about the planets.
Let's get on to the planets. Okay, so let's turn to the planets. Well, the two inner planets, Mercury and Venus, are actually very hard or impossible to see this month. Mercury's really low on the eastern horizon before sunrise. Be very difficult to spot. I wouldn't even bother, to be frank. It's only going to be a few degrees above the horizon in this sort of pre-sunrise glow, the dawn glow. So if you've got any trees or houses or things blocking your view out to the east, you're not going to see it. So don't bother. Venus, it's already lost in the dawn glare, really, of the sun because it's heading for what's called superior conjunction on the 23rd of October. Superior conjunction is a term that's used to just say that a planet's on the other side of the sun from us, or at least one of the inner planets is on the other side of the sun from us. A conjunction is when two things line up. So if you've got Venus on the other side of the sun, then that means the sun and Venus are in the same direction as you see them from Earth. So superior conjunction is when it's on the other side. If the Venus is around this side, which does happen, of course, and it's between us and the sun, that's called an inferior conjunction. But again, because it's in the direction of the sun, you don't see it because it's lost in the solar glare. Venus will be back in our skies towards the end of November. So October and November, we sort of won't get to see that. Mars is slowly getting closer because it's heading towards opposition in December. Now, opposition is when the sun and a planet are in opposite directions as seen from the Earth. So the sun's that way and the planet's 180 degrees that way in the other direction. What that means for a stargazer or an astronomer on the ground here on Earth, as the sun's going down in the west, the planet's coming up in the east, and that means you've got all night to look at it. And opposition is roughly the same time as when a planet is at its closest to us as well. It can vary by a few days or a week or so, but it's essentially, opposition also means closest approach, essentially. And when a planet is closest, that means it looks at its biggest in apparent size when you look through a telescope. So that's really when you want to see any of the planets. So for Mars, that's going to be in December. But at the moment, you can see the red planet rising above the eastern horizon shortly before midnight, and it'll get earlier and earlier as the weeks go by. Jupiter was at opposition last month, actually, in September, so it's still really well placed for viewing in the northeastern sky after sunset. When the sun goes down in the west, you'll see this big bright light out there in the sort of northeast, and that is Jupiter. You can't miss it because it is really big and bright. And finally, we've got Saturn. It's nice and bright too. Its opposition was a couple of months ago. So it's now in the northern sky after sunset. For us here in the south, if you're up in the northern hemisphere, just swap those directions. It'll be in the southern part of the sky for you. It's really easy to spot because it's a sort of a fairly brightish star-looking thing with a yellowish tinge. And a small telescope, of course, will show you its ring. So if you've got a telescope of your own, or your neighbour's got one, or a friend's got one, or someone in the family, have a look through because it looks really, really spectacular. You'll see the planet itself, you'll see the rings, you'll see the shadow of the planet falling over the sort of far side of the rings. Really gives it a 3D look, more so than any of the other planets, I think, because of the shadow effect. It makes it really seem as if this actual physical object there is floating in space, sort of just in front of you. Everybody loves the view of Saturn through a telescope.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.